Yes, we want to look at something called the modulus argument form of a complex number. In this case, this one sometimes called polar form of anyone on a complex number. So if we have this, someone should know that we can consider a complex number. Suppose z equals x plus what yi. You come and put this one on a complex plane, that you can form an Gann diagram. Real axis, then this one is imaginary axis. So you see that this is x, and then this is what? Y, because this is now a point x what? xy. So when you do this one here, you see that this is our complex number z, and this point now is now known. So what have you done? You see that when you have plotted this complex number here, we know one thing, that from here up to here we have x, then from here up to here we have what? From here up there we have y. So in this case, we have this distance of the complex number from here up to where? The one we can call what? The one we can call r, the modulus of that, the length of this one from here up to here. So you see that this one is a right angle, so it will always be at what? At 90 degrees. So what do? We use someone can assume the because you know very well your trigonometry, that sine of any angle which is here, this is, if this is theta, the one we are calling the argument, sine of theta will be equal to opposite, of which the opposite of hypotenuse. So our opposite becomes the y over what? Over hypotenuse, which is what? Which is r. So you see that if sine of theta equals y over r, so you say that our y will be equal to r sine of theta. That's what we are having. So we see that we can also consider cos of theta, which is the cos is always adjacent over hypotenuse. So our adjacent is x over r. So in this case, we have cos of theta, which is equal to x over r. This one implies that our x is equal to r cos of what? Cos of theta. When you look at these ones now, you see that we can call this one equation 1, and then this one equation 2. So in this case, we know that our complex number z equals x plus what? yi. So what we shall do, we shall substituting equation is 1 and 2 into z equals x plus what? yi. So we shall say that into z equals x plus yi. So our z will be equal to, where there is x, we are putting r cos of theta plus y r, which is sine of theta. Then what? Then I is now there. So we say that z r out, and we have cos of theta plus I sine of theta. So this is the one we are having. When it is in this format, it is what we are calling the modulus argument form. We are saying that now it is in its what? Polar form, whereby r is the modulus of a complex number. R is the modulus of the complex number. Then theta becomes the what? Our argument in this case. So you can write it like this, and this is the way how you can obtain. So any complex number can be written in this what? In this format. Sometimes we look at examples that are concerning this, and we come up with the way how you can denote any complex number in polar what? In polar form in that case. Now, if you want to get this, you can have an example in this case, and you say that let us consider z equals 1 plus I, and you see what we are saying. We begin by getting z bar, which is what? R, and is equal to 1 squared plus 1 squared in the root, and you say that this one is 1 plus 1, which is root what? We say that to get z bar, it is x squared plus y squared then under root. Our x is 1 and our y is what? Is 1. So after getting that, you go and get the what? The argument. How can you get the argument? It is always to get the argument of z. It is, we say that it is always advisable for us to first plot this. If this is the real axis, we shall have this one as what? Imaginary axis. So what do? We come and say this is 1 and then this is 1. So you can plot this, and then this is where your complex number will end. So this is your z, and then this is your theta that you want to get. Tan or theta equals 1 over 1, which is 1. So theta equals tan arc, some people call it tan inverse, which is equal to 45 what? Degree. Theta will be equal to 45 degrees pi over 1/8, such that it is pi over what? Over 4. So if it's pi over 4, this is your what? This is your theta now. So what do? You come and write, you know very well that in polar form, z will be equal to r, then cos of theta plus I sine of theta. So your z will be equal, your r is now root 2, then cos of theta, which is pi over 4, then plus I sine pi over 4 in this case. This is the way how you can rule that. You can do very many examples. You get the modulus, then you get the argument, and you substitute in that, and it becomes your what? It becomes your complex number in polar what? In polar form. At this moment, we shall pause from here. We shall continue from there next time.